sides.
Sir?
We get dx by, yes. Any doubt?
Yes, sir, just the previous step. Instead of getting minus 2v cos v, for me, I had one
You
v
could have,
cos, one plus and one minus, so I got cancelled out for me.
okay, it is correct. That means the denominator you got v sin v minus cos v, right?
Yes, sir.
Yes, it is correct. That means numerator, you could cancel that minus. It is correct. It is correct. Okay. So that one. The same method, you can proceed with that one. So taking reciprocals on both sides. So what do you get when you take the reciprocal use of dx by x dv, right? Ahmad? Dx by x dv is equal to right hand side also cos v minus v sin v upon minus 2v cos v. Then we take this dx to the right, dv to the right side. So by this step, we will be getting that variable separable form, and we can start the integration. Aryan, is it clear? Okay. So dx by x is equal to, what is dx by x? Cos v minus v sin v upon minus 2v cos v, and we have to take this dv to the right side. Online children also, is it clear the step?
Yes, sir.
We have done in all systems, we have done the same time. Okay, so now the next is variable separable form we got. So doing integrals on both sides. When there is a single term in the denominator, what is the integral, basic integral we apply? What is that, splitting into two parts, dividing term by term, right? So that is the next step. So this is variable separable differential equation. So this one, variable separable differential equation. Now taking integral dx by x is equal to integral cos v minus v sin v upon minus 2v cos v dv. Like this, we can do the integral. Integral of dx by x is, Sophia, integral dx by x is 1 by x dx. What is 1 by x integral? Log mod x, right? Log mod x. Practice. Log mod x is equal to here by term-wise division. Term-wise division is cos v by what is that? Minus 2v, right? Minus 2v. Yes, cos v by minus 2v cos v. Okay, dv is there. Minus integral. Minus, if I take outside, v sin v by minus 2v cos v. That minus by minus will become plus, right? Yes, second term is plus, first term is minus. But for lecture Raj, you are getting the same step by this, right? The second term, that plus term, you will be getting as the first one, right?
Yeah, yes, sir.
So minus cos v and the cos v will go. So this one will go. And we can take minus 1 by 2 outside. Then what is there inside the integral? 1 by v dv. 1 by v dv. Plus okay, so now minus is plus, we can cancel out v. Here we cut v. Then what do you get, children? Sin v by cos v. What is sin v by cos v? It is tan v. Tan v dv. Tan v dv. Both the integrals, So this is minus 1 by 2 log mod v. Minus 1 by 2 is there. So 1 by 2 is here also. You are correct. 1 by 2 integral tan v. So there is a 1 by 2 in the second name also. What is integral tan v dv? Basic integral. Log mod sec v, right? Integral tan x dx, we studied a log mod sec x. In the first page of indefinite integral, it is there. So integral, this is a log mod sec v. Log mod sec v. Then when both are log, we write the constant also as log. Okay, but for the convenience of taking 1 by 2 outside, can I write the constant as half log mod c? No problem, because log mod c is a constant, half log mod c is also a constant. So then we can easily simplify by taking 1 by 2 outside. So we are going to write the constant here as half log mod c. Half log mod c. Okay, there is no problem for writing like this. C is a constant, log c is a log mod c is constant, half log. Why do we write half log mod c? You understood? Because we can take half outside. Now I take half outside. So log mod x equal to left hand side is log mod x is equal to half into minus log mod v plus log mod sec v plus log mod c. Half into minus log mod v plus log mod sec v plus log mod c. Clear? Yes. Now we have to take this 2 to the left side. Simplification. Log type of questions, we simplify maximum using that log rule. So 2 log mod x is equal to, Hasnath got all these steps correct? Equal to minus log mod v plus log mod sec v plus log mod c plus log mod c. Okay. This 2 log x we can write log mod x square, because r log a is log a square. We want to write that again in the reference space. R log a is equal to log a square. I hope everybody knows that rule. Wherein R log a is equal to log a raised to r. R log a is log a raised to r. So here log mod x square. Log mod x square is equal to this one. Right now we can combine, or from here we can take it to the left side and combine. Okay, so I will take this also to the left side. Plus log mod v plus log mod v is equal to log mod sec v plus log mod c, that I keep here. This is log a plus log b form. Is it clear that first term 2 log x is log x square? Or we can write minus log mod sec v and we can make it division. Okay, that all same steps only. So now this will be log mod x square into v is equal to log mod sec v into c, or c sec v, c sec v. Now logs can be cut. X square v is equal to c sec v. Finally, we substitute for v. What is v is equal to in this question? V is a y by x. That means x square into y by x is equal to c into sec y by x. Now we cancel x and x square. So we get xy is equal to c sec y by x. This is the final answer. This also was general solution, right? These questions all are, we'll do particular solutions, general solutions. This question is also a general solution question. Yes. Hope you all completed and you understood this one. So y by x pattern questions, all of you understood, right? Y by x. So if in a question, y by x is specifically highlighted, you will apply that rule, or homogeneous, normal homogeneous questions, or we can apply this y by x type of rule. Okay. Yes. Next, x by y type of equation is right. Oh. Not compulsory. We can write like this. Okay, we can. Descriptive question, it is okay. But MCQs, we have to be more careful. MCQs, they will give a specific answer. Let's say it may be in the form of 1 by cos. And that cos they will take to the left side. Okay, like that MCQs. That is the reason why I taught you the rule of changing log to the other side. It will become e to the power, right? Log x to the base e is n means x is e raised to n. MCQs, the answer may be in that form. Okay, so that is the reason what in DPP I include 3 or 4 MCQs in every paper. Okay, every paper you can see MCQs, you can see. So that also how to practice well. Descriptive, I know you will do easily. Because most of the sums we practice descriptive, but the same type of theory is there in MCQs as well. Okay, next step. Solve 1 plus e raised to x by y into dx plus e raised to x by y into 1 minus x by y dy is equal to 0. Please write this. Solve 1 plus e raised to x by y into dx plus e raised to x by y into 1 minus x by y dy is equal to 0. This is a clearly x by y form of homogeneous differential equation. So look at the theory. What is the substitution? X by y is equal to v, right? But we have to write it in the form dx by dy is equal to, not dy by dx. Left hand side must be dx by dy. So I take the second j into the right side. Then we can write dx by dy. So the x by y forms. Those who have doubt, please check that theory part again. The type 2 you have written in the notebook last class. Dx by dy is equal to f of x by y. Then substitution is x by y is equal to v. Then differentiation also with respect to x or y. With respect to y. Differentiation is with respect to y. Yes. Those who got the idea can start. Others, once again, please listen here when I am writing. And then you can write it properly. 1 plus e raised to x by y into dx is equal to minus e raised to x by y into 1 minus x by y dy. This is the first step. Okay. So then what should be the left hand side? Dx by dy. So we take dy to the other side and 1 plus e raised to x by y to the right side. So we get dx by dy is equal to, what is dx by dy is equal to minus e raised to x by y into 1 minus x by y upon, what is that, 1 plus e raised to x by y. All of you understood this term? This is a homogeneous differential equation of type 2. X by y is the key in this one. When there is x by y, only we convert to this form. Other sums we write dy by dx form. Okay, y by x highlighted and normal sums also we write which one? Dy by dx. When x by y is highlighted in a question, in that type only we need to apply that type 2. Is it clear? All of you understood? Yes. So I will highlight that one. Can you see x by y here? Because of that x by y, we apply this form, type 2. So this is a homogeneous differential equation. So equation number 1, it is a homogeneous differential equation of type 2. Now the next step, substitution. What is the substitution, children? Put x by y is equal to v, or x is equal to vy. X is equal to vy. Yes. Ahmad Noor, did you complete till here? Done. All response, all of you completed. Plus y into dv by dx. So that is v plus y dv by dx. V plus y dv by dx. V plus y dv by dy, not dx, dv by which one? dv by dy. V into 1, because dy by dy is 1, plus y into dv by dy. Now you will substitute this in equation number 1. Is that clear? The derivative with respect to y? Yes. And in place of x by y also we substitute. What is x by y? X by y is equal to? Yes. So in place of x by y, you will substitute that one. Yes. So we get like this. Dx by dy we substitute. So equation number 1 becomes v plus y dv by dy is equal to minus e raised to v into 1 minus v upon 1 plus e raised to v. 1 plus e raised to v. Clear? Okay. You got the step. So then what to do? You have to take v to the right side. Same as there in the Bible form. So y dv by dy is equal to minus e raised to v into 1 minus v upon 1 plus e raised to v minus v. 1 plus e raised to v minus v. Okay, so I took this v to the right side. So then we take the LCM. LCM we take like this. 1 plus e raised to v, we multiply to v, right? Because v means v by 1. We have to multiply that. 1 plus e raised to v to this v and take the LCM. That means y into dv by dy is equal to minus e raised to v into 1 minus v into 1 plus e raised to v all divided by 1 plus e raised to v all divided by 1 plus e raised to v. Clear? Clear? Yes. Yes. So now when you open this bracket, we get, what do you get? Minus e raised to v minus into minus plus v e raised to v, then minus v e raised to v upon 1 plus e raised to v. Minus e raised to v plus v e raised to v, then minus v e raised to v is equal to 1 plus e raised to v. Clear? Yes. Now we can cancel out v e raised to v and minus v e raised to v. V e raised to v and minus v e raised to v. Yes. Then what do you get? Minus of e raised to v plus v upon 1 plus e raised to v. Minus of e raised to v plus v upon 1 plus e raised to v. Then taking reciprocal on both sides. Yes, all of you, Rachel here. Taking reciprocals on both sides. Yes. So what do you get when you take the reciprocals on both sides? Left hand side becomes dy by y dv is equal to minus 1 plus e raised to v. I kept that minus to the numerator, divided by e raised to v by v. Positive by negative is negative. That negative can be kept there in the numerator. Clear? Next, to convert it into variable separable, we will take dv to the right side. So we get dy by y is equal to minus of 1 plus e raised to v upon e raised to v plus v dv is variable separable form. So this step is variable separable form. So this is variable separable form. You can do integrals on both sides. Doing integrals on both sides. Examination don't write Vs like this, instead you have to write, which is a variable separable form of differential equation, because you get only one question. Okay, to show your knowledge of this chapter of solve, maybe, or maximum 2 questions. Okay. So that time you have to write it properly instead of a shortcut. So since we do similar lot of sums, I write Vs like that. Okay. So now you will do the integral. Integral dy by y is equal to minus integral 1 plus e raised to v by e raised to v plus v dv. What is integral 1 by y dy? Log mod y. What is the right hand side integral? Log mod denominator, because numerator is derivative of denominator. No need to write the detailed substitution. Okay, so like this, when you have done many questions, now integrals you are getting faster. Log mod denominator, log mod denominator. So please note down the reason. Here the numerator is d by dv of denominator. D by dv of denominator is d by dv of e raised to v plus v is e raised to v plus 1. That is the numerator. Because of that reason, the integral is log mod denominator. Numerator is derivative of denominator. Okay. No. Just for your understanding. Okay. There is still some doubts maybe there. Not for all. Now majority of all are okay, right? Yes. That means minus log mod e raised to v plus v. Plus, how will you write the constant? Log mod c, log mod c. Now we take minus log mod e raised to v plus v to the left side. So that means log mod y plus log mod e raised to v plus v is equal to log mod c. Log mod y plus log mod e raised to v plus v is equal to log mod c. Now this is log a plus log b form. Log a plus log b is a log a into b. That is log mod y into e raised to v plus v is equal to log mod c. Or we can write y into e raised to v plus v is equal to c. Substitute for v. What is v for this question? X by y. V is a x by y. So the final step is y into e raised to x by y plus x by y is equal to c. This is the general solution. Okay. Like this as another, when there is an x by y term in the question, you will apply the type 2 substitution. Other questions are no problem for writing that type 1. Okay. Shall we do one more question of x by y form? Yes, x by y form, we don't have more questions. So write one more question of x by y form. Solve the differential equation. Y into e raised to x by y dx is equal to x e raised to x by y plus y square dy, y square dy. Here also you can see that x by y form. Okay, so you will start writing dx by dy, but just a second, please look here. Here, if you compare with the other homogeneous, it's not as a general form of homogeneous. What's the reason? Can anyone say? Y square. One of the degree is more. But that doesn't matter when there is a fixed x by y or y by x. We can do with the same procedure of homogeneous. Okay. So that doesn't matter. At the end, there is a slight difference in the left hand side. Instead of dy by y, you may get only dy. Okay, only dy. That we can do the integral. That doesn't matter. Variable separable form unknown, you will get easily. So we start writing dx by dy. Start. Dx by dy is equal to dx by dy is equal to x e raised to x by y plus y square. Here the second term's degree is 2, but first term's degree is 1. Normally we get all the terms of the same degree. Divided by y e raised to x by y. But that doesn't matter since there is a fixed x by y. We proceed this by substituting x by y is equal to v. This is equation number 1. But here we don't write as homogeneous. Instead, we directly start the substitution. X by y is equal to v. Right. Put x by y is equal to v. Put x by y is equal to v. So x is equal to vy. Then differentiate with respect to y. Differentiate with respect to y. Differentiate with respect to y. Yes. So what do you get when you differentiate? Yes, please keep the camera on, other students. When you differentiate it with respect to y, we get dx by dy. Dx by dy is equal to v into 1 plus y into dv by dy by product rule. That is v plus y dv by dy. V plus y dv by dy. V plus y dv by dy. Okay. Substitute this into equation number 1. In equation number 1, you will substitute this. So equation number 1 becomes v plus y dv by dy is equal to x into e raised to v plus y square upon y e raised to v, y e raised to v, x into e raised to v plus y square upon y e raised to v. Is that clear? In place of x by y, we substituted. X into e raised to v plus y square upon y e raised to v. Now we have to take this, which term to the right side we can take. Okay, so we have to take v to the right side. V, the term v can be taken to the right side. So we get like this. Y dv by dy is equal to x e raised to v plus y square by y e raised to v minus v. We have taken this v to the right side, minus v. Clear? So which means x e raised to v plus y square minus vy e raised to v upon y e raised to v. X also we have to substitute. What is x? X is vy. X is vy. In the step we can substitute so that vy can be cancelled out. X also we substitute. What is x equal to? Vy e raised to v plus y square minus vy e raised to v by y e raised to v. Instead of x also we substitute here. Now we can cut this vy e raised to v. Clear? So we get y square by yes, I'm going to cut that one. Y square by y e raised to v, we can cancel y. So what do you get? Y by e raised to v. After this step, we take the again we can cancel one more term on left and right. Left there is y, right also there is a y. Can you see that one? Yes. So we can cut these two also. So this y On the left and right also we cut. Clear? So all of you please check these steps. If there is any doubt, you can ask. In the step, I substituted for x. X is dy. X is vy. Okay? Done? Now taking reciprocals on both sides. Taking reciprocals on both sides. Taking reciprocals on both sides. Taking reciprocals on both sides, we get dy by dv. Dy by dv is equal to e raised to v, or dy is equal to e raised to v dv. Dy is equal to e raised to v dv. Clear? Then doing integrals on both sides. Doing integrals on both sides. Integral dy is equal to, because this is variable separable form, integral e raised to v dv. This is variable separable form. So we do the integrals on both sides. Any doubt? No. What is? No. We just rearrange. That's it. Okay. So now we get y is equal to, what is e raised to v dv? E raised to v plus c. Substitute for v. What is v for this question? So this is the general solution. Okay. Next, we'll do a particular solution. Particular solution means one particular value will be given, and based on that one, we will simplify and get the particular solution. One particular value of x by x and y will be given. Okay. C is equal to. Next term. Okay, so please write a particular solution question. Solve x into sine square y by x minus y, this is in a square bracket, outside the bracket, into dx plus x dy is equal to 0. X dy is equal to 0. Y is equal to pi by 4 when x is equal to 1. Y is equal to pi by 4 when x is equal to 1. X sine square y by x minus y into dx plus x dy is equal to 0. Y is equal to pi by 4 when x is equal to 1. Yes. Here what to do?
So y by x form, right?
Y by x form. So y by x form, everybody knows dy by dx equal to, right? Left hand side must be dy by dx. For that, take that first term to the right side, and you can easily write dy by dx equal to. So because of the presence of this y by x, it is first type of homogeneous differential equation. So we start, and the degrees are okay. Degrees are first 1 for each term. Degree is 1. So we start. So in the second DPP, homogeneous questions are included. Okay, I did not put x by y question. Y by x questions are there. Today's DPP, I will include x by y questions. Okay, today's DPP, I am not including again y by x questions. And then linear we start today. That also some basic questions will be there. So that my intention is you will be completing it on the same day itself or the very next day and attending the next class with that confidence. Okay, and you are carrying that DPP with you in the printout and solution. That is my dream. Okay, because of your busy schedule, all that, the same system is going on. You are not coming to that track, but gradually within 1 or 2 days, you please increase your study time slowly. Okay. And there is a what is that? One paper is there in front of you. Yes, definitely you will do it. Okay, you have to do it. Yes, you think about the end result. What benefit I am going to get? Okay, is there any problem for scoring 95 above in the CBSE board exam or 100 out of 100? No problem. Aryan, 95 or 96. Any problem, Aryan? No. Okay, Yusuf, 97 or 100. Any problem? No. Everyone should think like that. So when you do like this, you will get each practice is adding one more mark to your paper. Okay. So please do. Everyone should do the practice without any problem. Okay, Hamad, great. Fine. So this is x dy is equal to minus of x sine square y by x minus y. Minus of x sine square y by x minus 1. So into dx. So using this minus, we can open the bracket. When we open the bracket, this y minus y will become plus, and this will be minus. So I write that step, then I take dy by dx. So y minus x sine square y by x into dx. So dy by dx is equal to y minus x sine square y by x all divided by x. This is the equation number 1. This is homogeneous differential equation of type number 1. It is clearly type number 1 homogeneous differential equation. So we put y by x is equal to v. Y by x is equal to v. Which means y is equal to vx. Now differentiate with respect to x. So we get dy by dx is equal to v into 1 plus x into dv by dx, which means v plus x dv by dx. Differentiate with respect to x. Substitute this into equation number 1. Please write till here. Yes, finish till this step. Now we substitute this into equation number 1, which means v plus x dv by dx is equal to left hand side. Right hand side y. Right hand side we can break like this. Last class also we did y by x minus x sine square y by x by what? X. So that y by x we can substitute directly. Right hand side we split that into 2 parts. So y by x we can substitute directly. What is y by x? Y by x is v. V minus sine square v. Then you take v to the right side. So we get x dv by dx is equal to v minus sine square v minus v. V minus sine square v minus v. Clear? So v minus v will go minus sine square v, and taking reciprocal, dx by x dv is equal to minus 1 by sine square v. What is 1 by sine square v? Reciprocal of sine square is cosec square. So we get minus cosec square v, or dx by x is equal to minus cosec square v dv. Dx by x is minus cosec square v dv. Clear? Now doing integrals on both sides. Integrals on both sides. Integral dx by x is equal to minus integral cosec square v dv minus integral cosec square v dv. What is the integral dx by x? Log mod x. So log mod x equal to minus integral cosec square v dv, direct integral formula, minus cosec square cot x, cot v, right? Cot v, because derivative of cot x is minus cosec square x. Integral of minus cosec square x is cot x. So including that minus cosec square x. So that minus we can keep here itself, because integral of minus cosec square v is cot v. Then plus c. Now we substitute for v. Log mod x is equal to cot y. Y is y by x plus c. This is the general solution. I keep this as equation number 1, which is called the general solution. This is the general solution. Normally we stop till here for a normal solved differential equation question. But here we have to continue. Yes, how to continue? Substitute the particular values of x and y. Yes, all of you completed till here that general solution. What are the particular values of x and y? Y is pi by 4 and x is 1. C is correct. So y is pi by 4 and x is equal to 1. Y is equal to pi by 4 and x is equal to 1. When y is equal to pi by 4 and x is equal to 1, substitute here. Log mod 1 is equal to cot pi by 4 by 1 plus c. Cot pi by 4 by 1 plus c. What is log 1? 0 equal to cot pi by 4. Cot pi by 4 is 1 plus c. So what is c is equal to minus 1. C is equal to minus 1. We got c is equal to minus 1. Clear? C is equal to minus 1. Then c is minus 1. Substitute this in equation number 2. Equation number 2. That will be the particular solution. So the particular solution is the equation number 2 becomes log mod x is equal to cot y by x, then minus 1. This is the particular solution. Log mod x is equal to cot y by x minus 1 is the particular solution. Hope you all understood this. So here is homogeneous differential equation. All the forms are okay, right? Yes, by practicing the other questions, you have to make sure that you will do it. All the sums, we apply the basic integrals only. Okay, so indefinite integral, you have to make it strong. Parallelly, you have to make your indefinite integral knowledge strong. Okay, so that will help you to do this type of question. Yes. Applications of integral, everyone finish your studies. Next test paper I have to announce. Application integral and these two together can I give or separate? Separate is enough. Okay, separate. Okay, two separate days I will give. Applications of integral can I keep that test paper on today, Monday, Saturday. Okay, by Saturday, you know it well. Applications of integrals is not so tough chapter, but practice it again. And from that chapter, 1 5-marker will be sure in the board exam, and one more question we expect in the 2-marker or 1-marker part. Okay, But one 5-marker, that is a highlight of the chapter. One 5-marker question we expected in the board exam applications of integral. Okay. Then after completing this also. Okay. By that time, you will reach at a stage of waiting for the test papers. Then vector 3D probability also you will enjoy, and parallelly we can start doing sample paper. Sample paper, slowly we have to, and when we introduce sample paper, by the time vector 3D when we do the sample paper, I will release. So sample papers also slowly we are going to start. Next, last is linear differential equation. After 1 minute break, I will start linear differential equation. By that time, I take that attendance. Ashida, attendance, Ashida. Ashida is absent now. Please keep the camera on, all of you, please. Ashida is absent. Ahmad Noor, Arjun Manoj, Aryan, Avril,
Present, sir.
Burhanuddin, Hasna, Joshua Josh,
Present, sir.
Lakshya Raj,
Sir,
Leah,
present, sir.
Luke,
Present, sir.
Mercy, Mufadal, Nicole,
Yes, sir.
Nikhil, Rakhav, Dash Krishna, Ranjit,
Present, sir.
Dash Krishna absent. Then Aradhi Jindal,
Present, sir.
Rima,
Present, sir.
Saad,
Present, sir.
Afia, Tariq, and Yusuf. Linear differential equation. That is the third and last topic of this chapter. Linear differential equation. That is also an easy topic. All right, children. So please write the subheading: linear differential equation. Linear differential equations. Linear differential equations. Please write. Linear differential equations. Linear differential equations. Type number one. Type number one. dy by dx plus py is equal to q. This is the type number one form. dy by dx plus py is equal to q, where p and q are constants. Where p and q are constants or functions functions of x. This is the type number 1. It is very easy to identify. It's a first order and first degree. These equations are first order and first degree. All of you know order and degree. dy by dx means first order, its power is 1. dy by dx plus py equal to q. There should not be any other coefficient for dy by dx. In case if there is a coefficient, we have to divide it by that coefficient and make like this. So dy by dx plus py is equal to q is the linear differential equation. So next we are going to write working rule. After explaining the working rule of type 1, we discuss type 2. Right. Working rule. The first step is we have to separate out P and Q or find the values of P and Q from that question. Okay, so that is step number 1. We should separate out P and Q and find their values. We have to separate out P and Q and find their values. Find P and Q, or simply you can write find P and Q. Okay, from the question, we have to find P and Q. Find P and Q. Find P and Q. Second step, we should find out an integrating factor, because all differential equation we solve by doing the integral. But this differential equation, in this form, we cannot do the integral. Okay, it cannot be integrated by this given form. There is a factor called the integrating factor. The role of integrating factor is same as role of a catalyst in a chemical reaction. That is catalyst in chemical reaction. That increases the speed of the chemical. I think it's good. It alters the chemical reaction, right? Like that you have studied, right? This year or last year you have studied it? This year, yeah. Okay. So same way, catalyst when we add, it increases the speed of the chemical reaction. Same way, here instead of catalyst, integrating factor. What is that? Integrating factor. Integrating factor we multiply. We cannot add and steer it. Instead, we have to multiply. Where do we multiply? Left-hand side and right-hand side. Okay, and when you multiply that integrating factor, same like catalyst increases the speed, we can easily do the integration. That is the role of integrating factor. So that integrating factor is e raised to integral p dx. What is that integrating factor? E raised to integral p dx. P is the value we can separate out. So e raised to integral p dx is the integrating factor. So right, the second step, find an integrating factor. Find an integrating factor. Find an integrating factor in bracket IF. IF means integrating factor. It is e raised to integral p dx. Very, very important. In first type integrating factor is e raised to integral p dx. After finding the integrating factor, multiply left-hand side and right-hand side by what? Integrating factor. So that is the next step. Multiply both sides of the linear equation, linear differential equation. Multiply both sides of the linear differential equation. The linear differential equation by integrating factor, and integrate with respect to x. Multiply both sides of the linear differential equation by integrating factor and integrate with respect to x. We have to multiply both sides of the linear differential equation by integrating factor and integrate with respect to x. But an advantage is left-hand side we don't have to write the detailed multiplication step. left-hand side solution, we can easily by heart. So solution is, last step, we write the solution. The solution is, left-hand side solution is like this, y into integrating factor. Left-hand side, now we need to spend time to multiply integrating factor. It is a fixed solution. What is that? Y into integrating factor. But right-hand side is not like that. We do integral and multiply the right-hand side by integrating factor. What is the right-hand side in the linear differential equation? So Q multiply by integrating factor and integrate. So it will be like this, Q into integrating factor, and you will do the integral with respect to x, because Q is a function of x or constant. So Q into IF into dx, that is the right-hand side. So this one, when you do, you will easily get that solution. Left-hand side solution, you have to by heart. What is the left-hand side solution? Y into integrating factor. But right-hand side, we multiply and do the integral. And this we get as a result of multiplying even the left-hand side. But that detailed steps, we don't have to write. So please go through that. Left-hand side, no need to write the detailed steps of multiplication. As a result of multiplication and integration, we get this simplified form, y into integrating factor. But right-hand side, we cannot write simply. We have to show that step. So please go through linear first type. Everybody understood? What is the general form? dy by dx plus py is equal to q. Where p and q are constants or function of x, functions of x. The first step, we have to find p and q from the question. Second step, what is the second step? Integrating factor. Because as it is, it's not an integrable function. So we have to multiply by integrating factor. What is the integrating factor? Here. So that itself can be asked as MCQ. Find the integrating factor. You will find e raised to integral pdx. Okay. So that will be MCQ instead of asking this full solved part. Then multiply both the sides by integrating factor and integrate with respect to x. And solution, left-hand side is y into integrating factor. Right-hand side, multiply and do the integrate. Okay, next type number 2. The same way we have tried type number 2, only a slight difference in type number 2. Please write type number 2. Type number 2 is dx by dy plus px is equal to q. Type number 2, dx by dy plus px equal to q. Dx by dy plus px equal to q. Where p and q are, yes, what are p and q here, you know? Constants or functions of y. Where p and q are constants or functions of y. Where p and q are constants or functions of y. Last one, it was function of x. Here, the differentiation is with respect to q. What was the first form? What was the first form? dy by dx plus py equal to q was the first form. And here, this is the rule, working rule. First step is separate out p and q or find p and q. Second step, find an integrating factor. Here the integrating factor, what will be, can you say? P dy. Last one, e raised to integral p dx, because p was function of x. Here p is function of y. So e raised to integral p dy, right? Find an integrating factor. Find an integrating factor. Find an integrating factor. Find an integrating factor like this. E raised to integral p dy. E raised to integral p dy. Third step is same. Multiply both sides of the linear differential equation by integrating factor and integrate with respect to y, right? Multiply both sides of linear differential equation. Linear differential equation by integrating factor and integrate with respect to y. And integrate with respect to y. Multiply both sides of linear differential equation by integrating factor and integrate with respect to y. Integrate with respect to y. Then fourth step is solution is, yes, how to write solution? X into integrating factor. Left hand side, last one, it was y into integrating factor. Here, x into integrating factor. Then integral, right hand side, q is there, that multiply by integrating factor, and integration is with respect to dy, y. Okay, so this is the solution for this type. So it is similar to the last one. So hope you all understood the two types, and when we apply it in the sums, it will be clear. In addition to this one, we have to know some log results, important log results, especially e raised to log f of x. When you find out the integrating factor, you will face that. Only we have written it. What is e raised to log f of x? E and log will go. It is f of x. E raised to log f of x is, so that rule we apply frequently when we find that integrating factor. So please write that additional note. Log results only. These are the log results. E raised to log of f of x. E raised to log of f of x equal to f of x. E raised to log of f of x equal to f of x. Another log result that we have used already, r log a. What is r log a? Log a raised to r. Okay, so these are the log results that we are going to apply here, especially the first one. E raised to log f of x is f of x. If there is any coefficient for log, you will take it as a power. Okay, then we can cancel out it. Yes. So here also, by the nature of the question, you will identify the type of linear differential equation. Once again, first type is dy by dx plus py is equal to q. Second type is dx by dy plus px equal to q. Px, p, the coefficient, it is x. Px equal to q. Okay. Yes. Start. Solve. Solve. Dy by dx plus 2y is equal to e raised to minus x. Dy by dx plus 2y is equal to e raised to minus x. This is of the form first type. So first of all, we compare it with the first type and write p and q. That is a first step. Okay, so this is clearly a linear differential equation of first type. So this is of the form. This is of the form, the linear differential equation dy by dx plus py is equal to q. Linear differential equation. Okay, so then we write p and q. P is equal to, what is p is equal to? and q is equal to e raised to minus x. P is equal to 2 and q is equal to e raised to minus x. P is equal to 2 and q is equal to e raised to minus x. Next step, we have to find out integrating factor, but we find the power first, then we do e raised to integral p dx. E raised to integral p dx is integrating factor. So we do integral p dx first. Integral p dx is integral 2 dx. What is integral 2 dx? 2x. No need to write plus c here because we have further calculation. So we write 2. Is it clear? 2 into integral 1 dx, that is 2x. Now, equal to e raised to, what is that? E raised to integral p dx, that is equal to e raised to 2x. Integrating factor is e raised to 2x. MCQs, this part alone may come, find the integrating factor, e raised to integral p dx. Now, for solve, we have the last step. Solution is, what is the solution for that first type? Y into integrating factor is equal to integral q into integrating factor into dx, right? This is the solution. So left hand side we get like this, y into e raised to 2x. Here their integration is done already. No need to do any extra steps for the left hand side. Right hand side we substitute q. What is q from the question? So e raised to minus x into e raised to 2x dx. E raised to minus x into e raised to 2x. E raised to minus x plus 2x, right? A raised to m into a raised to n is a raised to m plus n. So what is the result of this multiplication? E raised to x. So this is e raised to x dx. Integral of e raised to x dx is, so this is the solution. This is the solution. So easy, right? Here also basic integral knowledge, basic indefinite integral knowledge. Okay. This also can be asked as particular solution. Here, solve means only general solution. In case particular values are given, that is a common steps for all. You will substitute here and you will find out C. Clear? Yes. Next question. Yes, Ahmad. Next question is right. Solve dy by dx minus y by x is equal to 2x square. Dy by dx minus y by x is equal to 2x square. This is in the form of dy by dx plus py is equal to q. Okay, so you will write the same introductory step. This is in the form, this differential equation in the form dy by dx plus py is equal to q. Dy by dx plus py is equal to q minus 1 by x, and q is equal to 2x square. P is minus 1 by x and q is 2x square. P is equal to minus 1 by x and q is equal to 2x square. Clear? Yes. Now we do integral p dx. Integral p dx. Integral p dx is equal to integral p dx equal to integral minus 1 by x dx. Is that clear? That minus 1 by x because coefficient of y. Minus log mod x. Minus log mod x. No need to write plus c minus log mod x. Even mod also we cancel when we find that. Integrating factor will be next step. Integrating factor is e raised to integral p dx. That is e raised to minus log mod x. Minus log mod x. We can take that minus 1 as the power of x, right? R log a is log a raised to r. So how will you write x to the power minus 1, right? X to the power minus 1. Is that clear? R log a is log a raised to r. So x to the log x raised to minus 1. Log x raised to minus 1 means 1 by x. E raised to log of f of x. What is e raised to log of f of x? F of x, only f of x. E raised to log of e and log will go. It is only f of x. So what is the result of this? 1 by x. No need to write again mod. Here it is 1 by x. This is very, very, very important step. All of you understood this. Even this calculation can be asked as 1 marker. Find the integrating factor. Is it clear? Yes. Now the final step. Solution is yes. How will you write the solution? Y into integrating factor is equal to integral q into integrating factor dx. That is y into 1 by x equal to integral q into, what is q? 2x square. So 2x square into 1 by x dx, which means y by x equal to 2 can be taken outside. X square and x will go x dx. Again, basic integral. Clear, Aril? What is integral x dx? X square by 2. So the answer is y by x is equal to 2 into x square by 2 plus c. We will cancel out this 2. That is y by x is equal to x square plus c. Y by x is equal to x square plus c is the answer. Y by x is equal to x square plus c. Clear? So this is the method of doing first type. First type we have more questions. We have the time to do one more question. Okay, we'll discuss that next class. So next class we will complete this chapter. Okay, we will finish this chapter next class, and I'll give you the daily practice problem based on the sums till this part. Okay, linear differential equation, and first of all, please practice the sums which is already done in the class, and then we have to do. And the DPP1, those who completed solution, if it is required, you can do a self-verification. Okay, if you have done. So that you have to send me your paper, okay? Just as a PDF, you can scan and send it to me. So I will send the solution to those students. So completed DPP1. Okay, like that, DPP2 also. The solutions I can give you so that you can verify each of your answer. Okay, how many of you completed DPP1? Yes, please send me a message, okay? DPP1 I already sent, right? Yes, DPP1 already sent. That you have to verify each answer. Don't try to copy simply, okay? Check each answer. If there is any doubt, okay? Still, if there is any doubt, you can ask, okay? So like that, thoroughly you have to study each topic, okay? Thank you all.